Welcome to The Explainer. I am honestly so excited to jump into today's topic because we are going to completely dismantle a massive, persistent myth in web security. For years, developers have been told that if you just lock down your front door, if you strictly validate the data coming into your application, you're perfectly safe. Well, we're going to see exactly why that just isn't true, and we'll uncover the actual hero of web security, which is output encoding.
So, here is the fundamental conflict we face as developers. Yes, input validation keeps objectively bad, malformed data out. But what happens when the data you actually need to accept contains the exact same special characters that hackers use? Think about an Irish surname like O'Brien. It's got an apostrophe in it. You can't just ban people named O'Brien from using your app because their name might break a SQL query. Or what if you run a coding form? Your users legitimately need to post HTML comments or JavaScript snippets containing angle brackets and curly braces. You literally cannot reject all of that. You just can't whitelist your way out of reality.
And that brilliantly illustrates the core truth we need to accept today. Input validation is a myth without output encoding. Now, don't get me wrong, input validation is absolutely crucial, but it is not sufficient on its own. Since some data legitimately contains dangerous characters, output encoding is the actual safety net. It's the flip side of the coin. It guarantees that even if a malicious payload somehow sneaks through your front door, it gets completely neutralized and rendered totally harmless by the time it reaches your user's browser.
Okay, let's map out where we're headed. First, the XSS threat. Second, context is everything. Third, framework footguns. Fourth, defense in depth. And we'll wrap it all up with a rapid-fire review.
Section 1. The XS threat.
We really need to remember that data on its own is not inherently bad. A string of text is just a string of text, right up until the moment it gets exploited. The main villain we're defending against here is Cross-Site Scripting, or XSS. It's consistently one of the most common web app vulnerabilities out there, completely dominating the OWASP top 10, where it's actually now merged into the A03 injection category for 2021. And XSS basically comes in three distinct flavors. You've got reflected XSS, where malicious input is immediately echoed back to the user. You have stored XSS, where that dangerous input gets saved to your database and served up to totally innocent users later on. And then you have DOM-based XSS, which is incredibly sneaky because it happens entirely inside the client's browser without the server ever even seeing the payload. But here's the really good news. Proper output encoding stops every single one of these in its tracks.
Section 2. Context is everything. Data is essentially a chameleon. It changes entirely based on its environment. Think of it like a Trojan horse. The string script alert 1 is perfectly harmless while it's just sitting asleep in your database. It's literally just text, but the absolute millisecond you pull that exact same string out and drop it into an HTML paragraph, boom, it wakes up. It transforms from a sleepy database string into an active, executing attack running inside your user's browser. The fundamental concept of output encoding is that data is only safe in its own context.
This brings up a set of rules you should probably just commit to memory, because this is the critical point that trips up so many developers. You have different universes in a web page, and every single universe speaks a completely different language. If you're dropping data into an HTML body, you need HTML entity encoding. But if you drop it into a JavaScript block, HTML encoding is utterly useless there. You need JavaScript string escaping. Putting it in a URL, you need URL % encoding. CSS, CSS escaping. You must encode for the specific target context. Using the wrong encoding for a context is functionally the exact same as using no encoding at all. It leaves you completely wide open. Let's look a bit closer at the most common context, which is HTML. HTML entity encoding neutralizes characters by converting them into harmless equivalents. So the less than sign becomes &LT semicolon. Greater than becomes &GT semicolon. The double quote becomes &quote. But listen to this. This is super important. The ampersand itself must become &AMP semicolon. And you absolutely must encode it first. If you don't encode the ampersand first, an attacker can literally feed you partial entities, and your own encoding process will accidentally complete them into valid, dangerous HTML entities. Now, thankfully, if you use modern templating engines like Ginger 2, ERB, or Thymaleaf, this whole thing happens automatically, so let them do their job. Please, don't disable auto-escaping.
Section 3. Framework footguns.
Because, look, even with modern tools handling a lot of this automatically, there are still specific traps that developers manage to step on. For instance, if you write React code, you have definitely seen this property. The developers at Facebook did not name it dangerously set inner HTML just for fun. It is a massive hazard warning. It completely bypasses React's normally excellent automatic JSX escaping. When you use it, you are basically telling the framework, hey, I know exactly what I am doing, turn off the safety. And if you get it wrong, you have just manually introduced an XSS vulnerability.
Let's see how this plays out with DOM-based XSS. This happens when an attacker controls a source, like the URL hash, and it flows into a dangerous sink that executes code. Things like inner HTML and document.write are incredibly dangerous things because they actively parse and execute HTML. But consider the safe alternative, which is text content. Using text content to insert plain text into the DOM is entirely safe because it absolutely refuses to parse HTML. It treats everything it gets as pure, unadulterated text.
So here is your rapid-fire correct toolkit. Working in Python, use html.escape and url.parse.quote. In React, lean heavily on JSX auto-escaping. It's honestly one of React's best security features. Never, ever concatenate strings to build HTML. If you absolutely must render user-supplied HTML, you have to run it through a sanitizer like DOM Purify first, just to strip out any scripts and event handlers. And when you're dealing with URLs, always use encode URI component. Avoid encode URI, because that one actually misses crucial characters like the ampersand and equal sign, which attackers absolutely love to exploit in query strings.
Section 4. Defense in depth.
Look, even the best developers make mistakes. So what happens if your primary encoding defense misses something? Well, you need a backup parachute. And that backup parachute is your Content Security Policy, or CSP. It's an HTTP header that tells the browser exactly what is allowed to execute. Here is how you deploy the strongest version of it. Step 1. Send the header. Step 2. Generate a mathematically unique random nonce on every single page load. Step 3. Apply the strict dynamic rule. And step 4, by doing this, you block all inline scripts. That means even if an attacker finds an injection flaw and drops a script tag into your HTML, the browser's going to look at it, realize it doesn't have the secret cryptographic nonce for that specific page load, and it will flat out refuse to run it. You are literally starving the XSS attack of the inline scripts it relies on. It is a brilliant second layer of defense.
Section 5. Rapid Fire Review. Okay, we've covered a lot of ground today, so let's shift gears and do a rapid-fire review to really lock these concepts in. Get ready. Here is question number 1. Think back to the very beginning. What is the main villain? What is the primary attack that all of this output encoding is actually designed to stop? I'll give you a second.
Exactly. It's cross-site scripting, or XSS. And remember, output encoding protects against all three forms: reflected, stored, and DOM-based. By neutralizing the data based on its context, the payload never gets the chance to execute.
Question number 2. Let's test your knowledge on context. Why is it that taking perfectly HTML entity-encoded data and dropping it right into a JavaScript block is completely useless?
Because they speak entirely different languages. HTML encoding doesn't touch the special characters that JavaScript actually cares about, like backslashes, single quotes, and new lines. Inside a script tag, an HTML entity is just a harmless string to HTML, but to JavaScript, it might be the exact payload needed to break out of a variable. And a quick warning here too, using JSON.stringify inside an HTML script block isn't totally safe on its own either, because you still have to encode those angle brackets to prevent the attacker from just closing the script tag early.
Last quiz question. We talked about framework footguns. Which specific React property turns off all the safety rails and completely bypasses automatic escaping?
Yup, dangerously set inner HTML. Like we said, the name itself is literally screaming at you to be careful. Output encoding is not some advanced niche trick, it is a fundamental requirement of web development. If you're going to use this prop, you must bring your own protection, like DOM Purify.
Which brings us to our final thought for this explainer. Modern tools and templating engines are incredible, and yes, they do a ton of the heavy lifting for us. But keep in mind, the attacker only has to be right once, and you have to be right every single time. So I'll leave you with this. Do you know exactly where your framework's blind spots are? When you look at your own codebase today, are you absolutely sure your data is safe for the specific context it's living in? Go check. Thanks for joining me, and keep learning.